Hi, I'm Chris with Sanderson Test Prep, and in this video we are going to take a look at graphing polar equations. So if you've gotten introduced to this concept already in class, you might have already heard some terms that sound a little confusing or intimidating because they have a few complex words in there. They have limicons and rose curves and lemniscates and so forth. So we're going to start easy, and in this video we're going to take a look at how to graph circles from polar equations. So these are the three keys here that we're going to look at for polar equations. These two base forms of r equals a cosine theta or r equals a sine theta, when you have a coefficient in front followed by a cosine theta or a sine theta, nothing in front of the theta, it's just one theta, then that's indicative that we are going to be looking at something that is circular in shape, and the value of a is going to tell us the diameter of that circle. Now, to look at each a little bit more specifically, so a lot of us are familiar with cosine and sine and associating the cosine values with an x or horizontal coordinate and sine values with y or a vertical axis. And that's exactly what we're going to do here, is we're going to look at the circles that we're going to draw, and when you have a cosine theta, that means that the circle is going to run along your horizontal axis. And when you have a sine theta, it's going to run along your vertical axis. So now let's take a look at the value of a and see how that's going to determine the circle that we draw. So if we had to guess for cosine, when we're talking about along the horizontal axis, so if we think of pointing in the, so zoom in on that one a little bit. If we think of pointing in the positive or negative direction, well, that's going to correlate, and hopefully this seems a little bit intuitive, with a positive or negative value for a. So if a is positive, that means that your circle with a diameter of a is going to start at your origin, and it's going to be drawn out to the right in that positive direction. And then vice versa, if we had a negative value for a, we would start at the origin, and that circle would be drawn extending out in that negative direction. So a positive value for a, circle starts at the origin and is going to be directed out to the right, negative value directed out to the left. So let's take a look at an example of that. We'll start with a positive, we'll do a couple negative examples afterwards. So here, if we had something like r equals 4 cosine theta, so that means our diameter is 4, and then because it's a positive, and because it's cosine, so that means we're along the horizontal axis out to the right. So we're going to have a circle that points out to the right, and here 4, 0 would be the coordinate for the endpoint of that diameter. And once you have your circle drawn, depending on the question being asked, you can do a lot more with it. You can find the corresponding either radius, area, circumference, arc lengths, so forth and so on. Whatever might be asked, that's all going to be the same kind of process that you did when you first learned how to graph circles in standard form. But here, with a polar graph for a circle, we just want to remember cosine is our x-axis, and positive a along the x-axis means that that circle is going to extend out to the right. Now let's take a look at an example for sine. So again, here we'll start with a positive. So let's say r equals 2 sine theta. So if we have a positive 2. So let's take a guess here. We talked about our values for a along the horizontal axis, worked out quite intuitively, right? Positive was to the right, negative was to the left. Well, now let's look at the vertical axis. And let's take a guess here. If we're looking at a positive value for a, do we think that's going to extend up or down? So hopefully you just said up. So if a is positive, it means your circle is going to start at the origin and extend in the upward direction. If a is negative, it'll extend downward from that origin. So you'll have, for positive, a circle like this, or for negative, a circle like this. All right, let's try it out. So here for r equals 2 sine theta, we're going to have a circle that extends along the vertical axis in that positive direction, so it extends upwards, and it's got a diameter of 2. And then again on this, depending what other questions you're asked, you can figure out the center point of this would be 0, 1. And you could figure out the radius of this is going to be half of that value of a. So if a is the diameter of 2, the radius is going to be 1. And you can use your circle knowledge to answer any other questions you have about this circle. So that's how that's going to look for graphing circles in from polar equations. And let's take a look at just 2 more quick examples. We'll include some negatives just to make sure we're comfortable recognizing those. So here we'll do r is negative 3 cosine theta. And we'll do r is negative 5 sine theta. And if you want to pause and try it out on your own real quick, you can. But if you want to jump ahead and get right into graphing those. So negative 3 cosine theta. Cosine means we're on our horizontal axis. Negative 3 means we're pointing to the left. So that's going to extend from the origin out to the left. And it's going to have a diameter of 3. So the endpoint of that diameter would be at negative 3 comma 0 for that circle. And for sine, we're along the vertical axis and we're going in the downward direction because a is negative. So this would be a slightly larger circle that goes in the negative direction. And so the endpoint of that edge of the circle there would be at 0, negative 5. And like we said before, you can then use your circle knowledge to answer any additional questions that you're asked about these. But that's our start of graphing polar equations. We'll get into some of the more complex versions of graphing polar equations in our upcoming videos. Thanks for watching.